We got some solid questions after our video on aligning the Cummins engines in Tangaroa, and in this video we're answering them. Thanks to everyone who took the time to ask. You had great points, like why we didn't use rubber, what this repower would have cost if we didn't do the work ourselves, whether we recheck alignment after launch, and if the hull flex is enough to matter. A few of you asked about U-joints in the drivetrain and whether we accounted for sag. And then there was one question that really made me stop and think. Let's get to it.
Hey guys, welcome to this week's Q&A on our video on the shaft alignment on the Cummins engines. We are out on the Great Siberian Sushi Run. This video is being recorded from Village Cove, way north of Bramham Island, up inland. So we're tucked way back in the fjords on this. Beautiful, beautiful cove. We're going to get to the questions. Make sure you stick around till the end. We've got one that was a bit more of a techie one, made me think a bit, so stick around. We're going to start off with Mike Milburn, 7823. Would there be any advantage to use a U-joint in the drivetrain, or would it be too much work moving parts for relative gain? A random question, you had mentioned a while back about the rudder further aft. Wouldn't that cause a weird crabbing effect? Why ask these questions now? Don't know. Don't know why, but it just popped into my pea brain for no reason. So yes, on the U-joints, they do actually have products for that. The one that pops into mind first off, and I actually looked into these, is the Python drive. And what it does is, it's exactly that. It does a U-joint, or I should say a shaft with U-joints on either end, and it just provides everything that'll suck up any misalignment. It also separates all the vibrations from the engine, the thrust loading from the engine to the propeller. Therefore, you can run super soft mounts on the engine, and that reduces the amount of vibrations being transmitted to the hull, which is always a good thing. So you'll get less noise, less vibration, good benefit. But as I was saying, you have the thrust loading. So you can't just put a drive shaft in there. You have to add a thrust bearing in as well, because as it sits, the transmission handles all of the thrust loading on that engine and a propeller assembly. So all that force coming in gets transmitted to a big thrust bearing within the back of the transmission. That gets fed down through the engine mounts into the stringers, and that's what pushes the boat. So without that thrust bearing, you'd have issues. As for the rudder, I don't see that it would cause any crabbing issues. There would be obviously a difference in angle between the front rudders and the rear rudders, because the pivot point will be different. That might be a calculation I'll have to figure out in the future, but I don't see any negative effects from it. Next question up is from Johnny P. 4886. Did you account for the sag caused by the weight of the coupler and the shaft overhang? That's actually a great question, but no, I did not account for that. I'm not sure that it would make a lot of difference in this application. Maybe it would. We've noticed no vibrations or anything like that, no crazy movements on the shaft, but maybe it would. I didn't really put a lot of thought into that, but that's a good question. Next question up is from Rick H. 3694. Let's talk bottom paint. I just need to understand something. You have a lot of coats of different coatings. Since copper paint does not touch the aluminum hull, why not use it? I know there's a reason, I just don't know it. Looking forward to the cruise. Honestly, we've been kind of experimenting a little bit. We've done some reading. We've had a lot of comments saying that no issues using copper bottom paint as long as you've got a good layer of epoxy barrier coat, which we do. I think we've got like 8 or 9 coats, something like that. Very thick layer there. So we've started to actually experiment. This last time we've hauled out, we've done some copper paint around the water line, and we're gonna see how it kind of holds up and make sure that it's not gonna be doing anything weird. But I think we might be doing a switch to copper paint with it. But we'll see in future videos. We'll let you know how it goes. We've got a question from Jim Wright, or I guess more of a statement from Jim Wright, 3236. How did you align the center lines of the shafts? Oh, it is a question. I hope everyone who watches this realizes that there are dedicated training programs for this procedure, along with engineered solutions for preventing this hassle. Think bell housings on motor reducers and engine transmissions, for example. I really enjoy the content and continue to look forward to the next installments of your adventures. So the way that I aligned it was just basically measuring off of the stern tube. I'm certain it could be done to a finer extent. However, these are really long shafts, and the pivot point is all the way at the other end of the shaft where the other cutlass bearing is. So movements on this end of the shaft are pretty small. they have pretty small effects on the other end of the shaft, like really small effects. But what I also did is, being we have a 2-shaft setup with a muff coupler in the middle, I could actually butt those 2 shafts up together, and I can use a straight edge on the top and bottom side and side to make sure that I'm straight with the rear section of shafting. And that seemed to work out pretty well. Other than that, as far as run out and whatnot, we depend on the machine shop for that. The couplers were machined by the machine shop on shaft, so they should already be fit and centered for that stuff. Okay, next up we've got a question from Rural Living 8572. Great detail. It seems like this design places the propeller thrust on the rear transmission bearing. Is that right? Meaning the force travels through the rear bearing, transmission housing, engine block, ultimately through the motor mounts to the hull. Absolutely correct. You have explained it to a T. These transmissions have a big thrust bearing right at that flange, and all the load gets transmit through the transmission case. And being it's connected mechanically to the engine, all of that gets transmit through all 4 motor mounts, engine mounts, and down to the stringers of the boat, which pushes the boat through the water. I think I calculated somewhere in the range of close to 1,000 pounds of thrust per engine being transmit forward. I could be off on that. I am not an engineer for that stuff, but I think it's probably somewhere around there. Matthew Sellers 82 asks, what are your thoughts on hard, and he used the brand, Chalkfast mounts? When we got our boat, one engine had solid mounts and the other soft. Honestly, I've got zero experience with the Chalkfast stuff. Matter of fact, I had to look it up when you mentioned it. It looks to be some sort of like a bedding compound, if I'm looking at it correctly. So you'd build up a dam and you'd pour it in after you've got alignment there. I mean, I could very well be misunderstanding how all of that works, but I can't see how that would be any easier or more effective than any other method. I'm sure it would move less once that's in there. There's going to be less settling and whatnot, but it seems like that'd be a lot more difficult to do alignments in the future if something changed. So I think personally I'd stick to the soft mounts. I also can't help but think that there'd be a lot more vibration being transmitted to the hull through that. Once again, I could be wrong. Never used Chalkfast before, but that's my take on it. So I've got a question here from Kinsiler 9208. Could you explain to everyone why engine and shaft are precisely aligned rather than maybe using a double set of U-joints? I guess for starters, and I did briefly get into this, thrust loading. So you can't just use a set of U-joints and a drive shaft. You have to have something to take that thrust loading. Because obviously if you try to transmit thrust loading through U-joints, that's not really going to end well. So usually what they do is they've got a big bracket that's got a thrust bearing built into it, and that's where all of your alignment would happen. So you do still have an alignment even with a bearing like that. However, it's obviously going to be a lot easier to move one big bracket around than an engine and transmission combination. Other than that, the only other reason I'd think to go to a direct shaft drive with precision setup is simplicity and cost. The U-joint setups like Python Drive, they're not inexpensive. They do work quite well and they allow you to run soft mounts, but they're pricey. And that's, was not going to be in the budget for what we wanted. There wasn't enough cost to benefit for us to do that. We've got a question from Homer J. Simpson, 2118. Why not use rubber as well? Just going back to the thrust loading thing, rubber, you can use it, and matter of fact, they do have some couplers. They're called Drive Savers, or I can't remember what the other brand is. They're a coupler that goes between the 2 shafts. They're more made for isolation and safety purposes. So if you have like a prop strike, they'll tear rather than damaging the transmission. However, one of the benefits is it does open up your tolerance for your alignment a little bit. You still have to have it pretty close aligned, but not quite as close. But the unfortunate bit is being there handling the thrust loading as well, they're typically a harder material. So yeah, you can't get away with a wildly variant alignment, just a little bit. Next up, good question from Rob Deaton 9910. Okay, the repower you performed, what kind of price tag would you estimate for any other non-tech people? I mean, we know from you on the engines and parts that cost, but what would the labor cost be of someone without the knowledge and tools? Most projects cost split or 1/3 parts, 2/3 labor. You were on the hard for a few months, but were you working on it every day? To go to the end of that question first, pretty much every day. It was an enormous job. We might not have been working 8-hour days. You know, we might have had some shorter days, but honestly, it probably would average out to a full day because there were days where we were working 12 hours or even more. Cost-wise, you know, marine mobile mechanics or even, you know, the mechanics that are working out of shipyards, I think around here they're up around 180 bucks an hour. So if you start adding up all the time, I think I kind of added up to around the $200,000 mark for labor side of things, and plus the parts as well. And I've had people tell me it could be anywhere between $200,000, $300,000 is what they would have expected that to cost if we didn't do it ourselves. So would not have been inexpensive, and there was definitely a lot of benefit for us to do it. I know a lot of people say, well, what's your time worth? Because you know, you could be working or whatever. I don't really include that because at this point I was already starting to shift over to being on the boat full time. This is a bit of a hobby for us as well. It keeps us entertained. We enjoy this kind of work. So I don't take that into account as much, but yes, to answer your question, if you were to pay for this and not do it yourself or not have the expertise in it, I would expect somewhere in the $200,000 to $350,000 range would be a good estimate for that. Mind you, with plug and play engines that you don't have to build a lot of the stuff like I did, you could probably shave off on the labor, but you'd be adding back on the parts costs. So who knows? Next up, we've got a question from JBBBDA, something like that. JBBBA. Will you recheck alignment to float? I've heard of plastic boats flexing a bit on the hard. Your tinny seems lengthy. Bon voyage westward. Thank you very much. Yes, I'll be doing the alignment again here shortly. We've got a little bit of miles on, got time for the boat to resettle in the water, got time for the motor mounts to settle where they're gonna be. So I'll probably be tackling that within the next few weeks here. We don't have any vibrations that I'm worried about, but I'd like to check it, make sure we're still in the ballpark for where we need to be. And on a similar question, Half a B asked, will the boat flex coming from hard standing to the water enough to change the engine alignment? It can, yes. Depending on the boat, we know that this boat does flex a bit. We've got some spots where you might have a door that is a little bit loose, maybe a little tighter when you're back in the water. It also moves around with heat. Aluminum expands and contracts a lot, so you'll find weird little fitment things when it gets to summertime and either things dry out or the aluminum expands with heat. So yes, it will move around. Whether it'll be enough to affect alignment, can't say for sure. I mean, just the engines moving under thrust loading or torque loading might even be enough to move it out of that set alignment. But is it enough to make a difference? Who knows? So next question up, I'm hoping I'm getting this right. Limoges Farmer 6326. He asked, are you guys enjoying your time at Port Hardy? I presume you can buy fuel and provisions there. And where are you heading to? Port Hardy was awesome. Not necessarily the whole Port Hardy thing, but we had our son in town, so we had a great time visiting with him. We didn't really get a proper goodbye to him when we were at our Bon Voyage, because he was out of town at the time. So it was really nice to get a proper goodbye with him and be able to spend some time. We did some great hiking around Port Hardy. We hiked up to a World War II bomber, DC-3. Had a great time, a really great hike, would recommend it to anybody. But as far as the provisioning and fueling, yes on both. They've got a great store up there that we were able to pack up a lot of fuel on board. And we also took on 400 gallons of fuel, just to give us a little bit extra to make sure we could make it up to Prince Rupert. Prince Rupert's where we'll take on our main fuel. That's the best pricing for us. So this was just to kind of get us by. We probably had enough, but I always like to have extra just in case. As far as where we're heading, we're actually here. So we're stopped just kind of north, I think maybe just north of Bramham Island, which is pretty much right across the straits from Port Hardy. We didn't go very far. There was a lot of neat stuff for us to check out here before we headed farther north. And so far it's been pretty awesome here too. We found some really cool old, I call them diesel donkeys. They're big floating mechanical barges with big like windlass or pulleys on them that are driven by diesel engines. Old diesel engines. Like these were labeled Cummins reliable engine on the main radiator shroud. But yeah, like logging history, and we found 2 of them yesterday, and they were both super awesome. They'll be in our videos on our Exploring channel if you want to check those out. So yeah, after this, we're heading up to Calvert Island, I think, over the next couple of days. We'll spend a few days there doing some great hikes, and then just slowly start bumping our way north. Maybe stop in Bella Coola, do some cruising around there, checking out some hot springs and whatever else we can. And we're not on a set schedule. We just go where we need to go when we want to go. I should also add, for all of you guys that don't like the fact that we have a bare aluminum boat, when we were in Port Hardy, we got run into twice at the dock in 4 days. Twice, both by other aluminum boats. If we had paint on our boat, we would have been immediately having to take care of that before corrosion set in underneath it. It would have taken tons of time to get that all sorted and patched up. For us, we just shrugged it off and went on our way. We didn't have to talk about insurance with other people. It did no damage to the aluminum hull sides. Exactly what we wanted. Next question up from Big Rock Auto. Cush drive, question mark. Cush drives are used pretty commonly in the marine industry, but usually they're between the engines and the transmissions. They just give a little bit of damping when you're going in and out of gear, and torsional damping on the pulses of the engine, keeping them from the transmission. But they're not set up for thrust loading, so we can't just put one of those at the back of the transmission. I guess gone into this in the other questions earlier. We need some sort of thrust bearing before something like that. But yes, that would probably work. That would certainly add a little bit of leniency on the alignment. But yeah, without a thrust bearing before the transmission, it's not going to work. Next question we got from How Are You Now 1477. Did you check the alignment frequently when new to check to make sure it settles well, and then less as time goes on, or is it pretty much a yearly set it and forget it kind of thing? Honestly, it's not even really yearly, and it's not necessarily more frequently at the beginning, short of I like to do a short check not too long after the initial launch with the new equipment, just because that's where your initial settling is going to happen. You will get mounts that will slowly squish down over the years. However, I wouldn't call it like a yearly thing. Honestly, there might be a set time that you should check it. I don't know that. I just do it when I feel it's necessary or when I get a vibration. And I would wager that there are a vast majority of boats that haven't had alignment checked in very, very long times that are plying the seas everywhere. So there's really not a set schedule as far as I'm concerned, but it is something that I like to keep my eye on. Last question here is from Henry Cole 5584, and Jabiro Crew 6970 chimed in on this same one. Why not some sort of flexible coupling to reduce the need for perfect alignment? And then Jabiro Crew asked, that was going to be my question, flexible or universal joints. Once again, we've touched on this earlier in this video. It's all thrust loading. You need to have some sort of a thrust bearing between the propeller and whatever coupler you'd be talking about like that, because they're not meant to take thrust loading. U-joints will not handle that, at least not for any particular length of time. They do have universal joints that do have a movement built into them, but it's just movement for differences. So for example, if we had some sort of a thrust bearing between the engine and transmission, and then we had a U-joint with some sort of a sleeve in it to allow it to move, all that's there for is just to take up the shift in, say, the rubber couplings on this side or the couplers on this side. Couplers, there was a comment on that in the comments. Yeah, you're just taking up the compression of the rubber. It's not meant for handling thrust at all. So yeah, that's same answer to that question. Gotta have a thrust bearing in there somewhere. All right, thanks for sticking around, everybody. It's time for question of the day. This week, the question came from Motivatin'. That's some careful work there, nicely done. So a variation on a question I asked a while ago about having to run long distances on one motor in case of a breakdown with the other one windmilling. Does it make sense to have coolant cross feeds between your transmissions so that the live engine could be cooling the windmilling dead-end driveline? Probably a lot of hassle for a low likelihood of probability, but I've wondered about this. Also, in the world of commercial aviation, it's common under certain circumstances to taxi an airplane on one engine heading into the ramp to save fuel costs after landing. If you had cross-feeding cooling between your transmissions, not only would you be covered if you had to run on one extensively due to a breakdown, but it would also make it possible for fuel savings in the right circumstances to alternate one and then the other engine. I'd be interested in your thoughts on this. That's a great comment, and quite honestly, that might even be a good idea. I've never really put a lot of thought into it. Some sort of a simple electric pump or even just running both the coolant feeds through both the heat exchangers some sort of way. I don't know how that would work, but probably individual electric pumps to keep coolant flow through there. But you would also have to pump the transmission fluid as well, the transmission fluid, the oil, because the pump and the transmission, when the engine is running, is what circulates it through. So you would physically have to have a pump to run that through. But yes, that would work. And I do plan to do some testing on that to see if we get much of a benefit just running off of one engine, and whether there's more of a benefit to have one transmission freewheeling and or one transmission locked out and the prop stopped. There's a lot of conflicting information on this online. It's a much debated topic, but if I can get real life examples on this, I'll try to. Right on. Thanks everybody for watching this week's Q&A. If you want to check out where we are or where we're going, hit up www.onboardtongaroa.com. We should have some live tracking pretty soon. We're working on that right now. So check it out, and we'll see you guys next week. For some of you following along, you might have noticed that we were under a tsunami advisory yesterday. There was the big earthquake in Russia, and they were expecting something to hit this coast. We are way back up in the fjords right now, if you want to call it that, well behind a tidal rapid. We had zero issues. There was no, I don't even think we saw any water movement here at all. I know some places, Hawaii I think saw some, obviously Japan likely saw it. Some of the coastal regions down to even California I think might have seen some, but we had nothing here. There was no movement. We were nice and safe and tucked in here. And hopefully that'll be the last of it. There's been, I think, 3 earthquakes since we left on our trip that were fairly substantial. So there's some plate movement happening up there. Hopefully it'll get its movement settled and we won't run into anything else like this in the future. So all good. Thanks for the warnings from everybody that sent it to us, and we'll see you guys next week.
If you haven't seen the original video where we walk through the full engine alignment process, check that out first. Aligning Cummins truck engines in our 78-foot yacht. We cover everything from custom mounts to getting the couplers just right. It'll give you the full picture before we dive into the questions.